Hi there, grade 8. So, our lesson for today is simplifying rational algebraic expressions. So, before we begin with simplifying rational algebraic expressions, so let us define first what is a rational algebraic expression. So, the following are examples of rational algebraic expressions. So, we have x minus 1 all over 2x plus 1, y minus 3 all over 2y plus 1. And then we have x minus 1 all over x squared minus 1. X cubed minus y cubed all over x squared plus y squared. And x squared plus 4x plus 4 all over x minus 4. With these examples, it is very clear that a rational algebraic expression is a quotient of two polynomials. So in other words, we can say that it is a fraction whose numerator and denominator are polynomials. So going back here, our task is to simplify rational algebraic expressions. So since this is compared to fraction whose numerators are both polynomials, so what we're gonna do is to reduce. This is like reducing a fraction to its lowest term. Okay, so in here, in these examples, the last three have to be simplified. The first two here are already simplified to its lowest term. Before we work on simplifying rational algebraic expressions, let us know how do we simplify rational algebraic expressions. Okay. So first, simplifying rational expressions is the same idea with reducing a fraction to its lowest term. Okay, so in reducing a fraction to its lowest term, we work on the greatest common factor between the numerator and the denominator. And then we will move out that greatest common factor. And that's how we simplify or reduce a fraction to its lowest term. Now, in simplifying rational algebraic expressions, it's necessary that we have the idea or knowledge on factoring. So that's the reason why we work first on factoring polynomials in preparation also to our next lesson, which is simplifying rational algebraic expressions. Because as what I mentioned, reducing a fraction to its lowest term is moving out the greatest common factor between the numerator and the denominator. So it's a rule that we must be aware or we have the knowledge on factoring polynomials since we are dealing with fractions whose numerators are and denominators are both polynomials. And take note that a simplified rational algebraic expression has no common factor, okay, except one between the numerator and the denominator. So when if so, then we can say that the said rational algebraic expression is already simplified. So before we work on HRA, let's go back with the previous examples. And I told you that these three rational algebraic expressions are not yet simplified. So you have to work on each by identifying their common factor. So, for example, with x minus 1 all over x squared minus 1. Now, x minus 1 here, class, is like a prime number. So, if it's a prime number, then its factor is the number itself and 1. So, likewise, we will just rewrite x minus 1 here and factor out the denominator. And recalling factoring, the denominator is binomial with operation subtraction and both terms are perfect squares. So what we're going to do to factor this out is to consider the difference of two squares or the difference of two perfect squares. So the factors are the extracted square root of both terms. One is addition, the other one is subtraction. So this is square root of x squared and square root of 1, which is 1. So 1 is addition, the other one is subtraction. So we have made use of factoring difference difference of two squares. Now, comparing the numerator and the denominator here, we see that there is really a common factor between the two. So we have to cancel out that common factor and rewrite the simplified form. Now, since everything is canceled on the numerator, we represent that by 1. So, when simplified, we have 1 all over x plus 1. Okay. So, when this is simplified, the result is this one. Now, for x cubed minus y cubed all over x squared plus xy plus y squared. So, we have to write the factor of the numerator here. So, this is the numerator is a binomial. So it's the difference of two perfect cubes. So the factors are one binomial factor and trinomial factor. So the binomial factor is the cube root of both terms here. So going back in our factoring lesson. So cube root of x cube is x, and then copy the operation minus, while cube root of y cube is y, times the trinomial factor for that one. The first term is the square of the first term here, and then the product of x and negative y times negative 1. So this is plus xy, and then the last term is the square of negative y. So this is y squared. Now, we don't need to factor the denominator since we see that the denominator is the same with the second factor of the numerator. So we will just rewrite x squared plus xy plus y squared. And then cancel the common factor. So when simplified, we have x minus y. You don't need to write x minus y all over 1. X minus y is like a whole number that the denominator is 1. But we do not write, for instance, 5 over 1. We just write 5. So likewise, we'll just write x minus y. But may I remind you that x minus y is different from 1 all over x minus y. That 1 all over x minus y is the reciprocal of x minus y. Likewise, 5 is not the same with 1 over 5. And again, 1 over 5 is the reciprocal of 5. Why am I saying that? Let's go back with the first example here. The numerator is cancelled here, so we represent that by 1. So 1 all over x plus 1 is not the same with x plus 1. Okay? And then lastly here, the numerator and the denominator are both factorable. Okay, so what we're going to do is to describe each polynomial, and then what factoring method are we gonna use? Like for this one, by inspection, the trinomial here, it's a quadratic trinomial, but particularly that one is a perfect square trinomial. So this is perfect square trinomial. And then the denominator is the difference of two squares. See, you should have a knowledge on factoring, because if you do not know factoring method, you cannot simplify a rational algebraic expression, because simplifying rational algebraic expression has something to do also with factoring. Okay, factoring is necessary. Okay, fact two squares. So let me write the factors of the numerator and the denominator here. Here. Okay. So I'm gonna write the factors of the numerator. So the factors of perfect square trinomial class in our previous lesson, this is just extracting the square root of the first term, copy the sign of the middle term, square root of the last term, quantity squared. So what's the square root of x squared? It's x. And then the operation of the middle term there is addition. X plus the square root of 4 is 2. And then quantity squared. For the denominator, this is the difference of two squares. So the factors are the sum and difference of the same two terms. So we will extract the square root of both terms. So the square root of x squared and the square root of 4. So we have binomial, two binomial factors here. Product on the sum and difference. One is addition, the other one is subtraction. And we'll get the square root of x squared and 4. So square root of x squared is x. Well, square root of 4 is 2. So these are the factors. Now, compare the factors of the numerator and the denominators. So they have common factor, and that's x plus 2. So we will cancel 1x plus 2 on the numerator. So there's only 1x plus 2 here. And then we'll cancel x plus 2. So we have x plus 2 all over x minus 2. So this is how we simplify this rational algebraic expression. Okay, so that's how we simplify. Let's work on more rational algebraic expressions to be simplified. So we have here x plus 7 all over x squared plus 8x plus 1. We know that x plus 7 is no longer factorable, and this is like a prime number. When so a prime number has no factor other than itself. So we will just rewrite x plus 7 here. And we know that the denominator is a quadratic trinomial. Okay. So we can find the factors by trial and error. Trial and error in the sense that we're going to consider the factors of the first and the last terms. Now, the factors of x squared will only be x and x here. And 1, of course, will be 1 and 1. Okay, this should be 7. Okay, let me change the given. So this was just typed wrongly. This must be 7. Okay, so since that is 7, it's still a prime number, and the factors are 7 and 1 only. So we will place 7 here. So again, this is 7. Okay, now, since everything is positive here, recalling how we factor using trial and error. So everything must be positive here. And since 7 is positive, so the factors of 7 will be a pair of positive. And by inspection, if we check the combination of the OI, the product of the outer terms and the product of the inner terms, this has to match 8x here. So 1 times x is x, while x times 7 is 7x, so we got 8x. So these are the factors really of the denominator. So the common factor has to be cancelled. And when simplified, this is equal to 1 all over x plus 1. Okay. Now, for number 2, it's not a perfect square trinomial, so we will do trial and error again. So we're expecting two binomial factors. We might consider one of the factors of the numerator. You might consider x plus 1 as one of the factors of the numerator because our goal here is to cancel common factor. So we're expecting that they have common factor. So we will consider x plus 1 as one of the factors of the numerator here. Now, if x plus 1 is one of the factors, the other factor should be, since this is 2x and we have x as one of the factors already, so the other factor must be 2x. So that when 2x and x are multiplied, the product is 2x squared. Likewise, if this is a 1, the other factor of negative 1 should be negative 1. So, when negative 1 and 1 are multiplied, the result should be negative 1. But most importantly, we have to check the middle term. Is the middle term match with the sum of the OI here? I mean, the product of the outer terms and the inner terms here. So the product of the inner terms is 2x, while the product of the outer terms is negative 1. When combined, it's x. So these are really the factors. And we will just copy x plus 1 and then cancel the common factor. So when number 2 is simplified, this is equal to 2x minus 1. Okay, so this is for number 1. This is for number 2. For number 3, again, we will just rewrite 5m minus 1 since 5m minus 1 is already simplified and has no other factor. And then this one is the difference of two cubes. So we have one binomial factor and a trinomial factor for this. And that binomial factor is actually the cube root of both terms here. And then we will consider the subtraction operation. So the cube root of 125m cube is 5m, while the cube root of 1 is 1. And then the trinomial factor, first term, will be the square of 5m here. And then the product of the two times negative 1. And then square of negative 1. So cancel the common factors. So we have 1 all over 25m squared plus 5m plus 1. Okay. Number 4, the numerator class is a perfect square trinomial. So the factors are the square of binomial. And that binomial is the extracted square root of the first term and the last term here. And we will consider the operation of the middle term here. So the square root of 25x squared is 5x. And then minus The square root of 1 is 1. Quantity squared. And then we'll copy 5x minus 1. Cancel the common factor, which is 5x minus 1. So we only have 5x minus 1 left as the simplified form for number 4. Now in number 5, take note that it's a quadratic trinomial, but it's not a perfect square trinomial, nor um, we cannot find a perfect binomial factors that would match with this one. So meaning we're expecting that the solutions or the roots for this quadratic trinomial are irrational. Now, what we will do is to concentrate on the factors of the denominator. And for the meantime, we will just copy as is the numerator. And the denominator is the sum of two perfect cubes. So the first binomial factor will be the cube root of the two terms here, and we will copy the operation of the given. So the square root of 64x cubed plus the square root, rather the cube root of 64x cubed plus the cube root of 343y cubed. So that will be the first factor. So we have 4x plus 7y. And then the trinomial factor, first term, is the square of the first term here. So this is 16x squared. While the middle term is the product of the two terms here times negative 1. So this is 4x times 7y. We have 28xy times negative 1. So we have minus 28xy. And then the square of the last term here will be the last term of this trinomial factor. So we have 49y squared. So after completing the factors of the denominator, comparing it with the numerator, so the second factor is the same with the numerator. So we're going to cancel that same factor. Okay? So we have 1 since the numerator is canceled all over 4x plus 7y there. So let's try to work on more rational algebraic expressions to be simplified. Now, this one is the difference of two squares. Okay? So the factors are the product or the sum and difference of the same two terms. So we're going to extract the square root of both terms here, and we will place here. So square root of x to the fourth is x squared plus square root of y to the fourth is y squared. Now, class, although this one is still factorable, but this is the same with the denominator. So, no need for us to factor this out. Instead, what we will just do is cancel x squared minus y squared because this is exactly the same with x squared minus y squared of the denominator. So, the simplified form is equal to x squared plus y squared. Okay, so for number 2, um, this one, both terms here are perfect squares. Both terms as well are perfect cubes. Now, you can do either, you can do factoring by considering either of the descriptions of the numerator. So you can work on factoring using the difference of two cubes or work on factoring using the difference of two squares. But if I were you, you consider the higher degree. So you consider working on the difference of two cubes. So if that's what we're going to do first, we know that the factors of 64x to the 6 minus 1 using the difference of two cubes will be, we will extract the cube root of both terms here, and we will copy this subtraction operation. So we have 4x squared minus 1. So this is the binomial factor. Now, how did we get 4x squared minus 1? The 2 here are the cube roots of the 2 here. So we know again that extracting the cube root of an algebraic expression is just dividing the exponent of the variable by 3. So we got 2 here. Now the trinomial factor, first term will be the square of this. So we have 16x squared. And then the middle term is the product of the 2 and times negative 1. So this is plus 4x squared. And then the last term is the square of negative 1. Now, looking at the denominator for x squared minus 1, it's the same here. So, this will be the factors. Now, if we're going to consider the other method, like we consider the difference of two squares, okay? So, this is solution for number 2 using difference of two squares, okay? So, we know that when the two terms here, if we get the extracted square root of the two terms here, we'll have 8x cubed plus 1 and then 8x cubed plus 1. And both terms here are still factorable. So we are working on the numerator, okay? And using the difference of two squares, the factors are the 2 here. Now, the 2 are still factorable and the 2 are not the same with the denominator here. So we still to factor this out. Like we're going to work on the difference of two cubes for both of these binomial factors. So the extracted cube root will be 2x plus 1. And then we have 4x squared minus 2x plus 1. For this, it's the same thing. Cube root of both terms. So, sorry. This must be subtraction. One is addition, the other one is subtraction. Okay. So the cube root of this two terms will be 2x minus 1. And then the trinomial factor is 4x squared plus 2x plus 1. All over now, the denominator, which is 4x squared minus 1. We know that the factors of 4x squared minus 1 are 2x plus 1 and 2x minus 1. And then we will cancel common factors. There remains 4x squared minus 2x plus 1, 4x squared plus 2x plus 1. Class, when you multiply the 2, this will result to this. This one or this one is the same with the product of this. So this is equal to 16x squared plus 4x plus 1. Same. We've got two different methods, but we come up with the same simplified form. But take note that this one is longer than this one. Okay? So for number 3, the numerator here is a perfect square trinomial. So the factors will be the square root of the first term minus the square root of the last term, quantity squared. So we have square root of 9x squared, 3x, minus square root of 49, 7, quantity squared, all over. Now, this is a quadratic trinomial, so we will find the factors by trial and error. Of course, we will assume that one of the factors of this trinomial is 3x minus 7. If one of the factors is 3x minus 7, so what should be the other factor? Since this is 3x, the other factor of 3x squared should be x. And then since we have values of negative 7 and we have the constant term equal to negative 7, the other factor should be positive 1. So we have to verify if the middle term minus 4x will match with the sum of the OI here. I mean, the product of the outer terms and the product of the inner terms here. Okay? So this is negative 7x plus 3x. So we have negative 4x, which is correct. So these are really the factors. Now, so we will cancel the common factor. So we will cancel 3x minus 7 here and 1 3x minus 7 on the numerator. So the simplified form is 3x minus 7 all over x plus 1. Okay, for number 4 class, the numerator here is the difference of two squares. So both terms are perfect squares. So the factors are two binomial factors. So do we get the two binomial factors? We will extract the square root of both terms and place it here. One is addition, the other one is subtraction. So square root of 16x squared is 4x, while square root of 25 is 5. So these are the factors. Now, this trinomial is a perfect square trinomial. So the factors are the square root of the first term plus the square root of the last term, quantity squared. So the square root of 16x squared here is 4x plus the square root of 25 is 5, quantity squared. So we will cancel the common factor 4x. So the simplified form is 4x minus 5 all over 4x plus 5. And for number 5, so we know that the factors of x squared are x and x, but we will not do that. Instead, we will just write this here. And x squared is common to both terms here, so we will divide both terms here by x squared. So when x to the fourth divided by x squared, we have x squared. And then x squared divided by x squared is 1. So common factor is x squared. So number 5, with simplified, we have 1 all over x squared minus 1. So this is how we simplify our rational algebraic expression. Now, another reason why we need to simplify rational algebraic expression, similar with fraction, whenever we perform operations on fraction, the answer has to be simplified or has to be reduced to its lowest term. Exactly on what we're going to do with simplifying rational algebraic expression. So it's necessary that we should know how to simplify because as we proceed with operations on rational algebraic expressions, we are required also to simplify our answer. So the next topic after this one will be the operations on rational algebraic expressions. Now, before I end my discussion, I'd like to note that simplifying rational algebraic expression, for us to arrive with the correct simplified form, it is necessary really that we have the knowledge on factoring. So you have to recall some factoring patterns that you have learned before you work on simplifying rational algebraic expressions. So that's it for now.